Hey everybody, welcome back to Economics, Chapter 5, Applia homework. This time I'm going over just question 2 in the homework, elasticity and total revenue. Two topics that are fairly important when you're pricing goods, so it's good to pay attention to this on the off chance you do some pricing at some point in the future. So here we've got a graph that shows the daily demand curve for bikes in San Francisco. I don't know why anyone would want to ride a bike in San Francisco because it's a little hilly, but apparently some people do. So in this case, we're looking at this demand curve that shows us that as the price goes up, the quantity demanded goes down, exactly what we could expect. Now, the first thing this question asks you to do is find total revenue. So total revenue, when the price is 100, 48 bikes are sold. So total revenue is 48 times 100. That's this area under here, or I did this also for you over here. Actually, I did 125 over there. Same thing. So it's the area of that rectangle. $100 times 48 bikes, that'd be $4,800, right? Is total revenue when price is 100 and output quantity demanded is 48. So the next piece of this question asks you to plot total revenue when the market price... Sorry, the deer are hanging out outside my house tonight and the dogs will not shut up. So for this question, we look at these different prices and we plot total revenue for each of those. So the first one, when the price is 50, demand is 60. We look at our demand curve, right, to figure that out. Total revenue then is going to be 60 times 50 or 3,000. So at 50 and 3,000, it's that point right there. Let's do exactly the same thing for each of those price points. And eventually you get a total revenue curve that looks like this. So here was the first point that we plotted on the other page. At 100, we sell, I can't remember how many bikes already, but you end up with this total revenue. 75, you end up with this total revenue. So it's based on that demand curve in each of the prices. What's interesting is that the total revenue increases for a while and eventually tops out and begins to decrease. So what that means is when you're increasing price in this range between 50 and 125, which is this point right here, fewer and fewer people are buying your bikes, but the increase in price is larger than the percentage decrease in quantity demanded. Beyond this point, however, when you try and increase the price above 150, people drop like rocks. All of a sudden you have no customers, your total revenue goes down, even though your prices continue to increase. And the reason total revenue goes down is because you've been increasing your price, and eventually people decide that they're very sensitive to that. So in this range, people were not particularly sensitive to the decline, to the increase in price. After that point, however, people were extremely sensitive to the increase in price. That's another way of saying in this area over here, price was inelastic, and over here, elasticity demand was elastic. So there was a big change in quantity demanded when you changed price a little bit. So if you were pricing something, here's your sweet spot, right, where you maximize revenues. But you can't increase price beyond that or you'll see your total revenue fall. The next part of this question asks us to figure out, by using the midpoint method, what the price elasticity demand is between point A and point B. So go back to that demand curve, and at point A and point B, what happens? So we actually know the answer already because we figured that out, right? That between point A and point B, where prices were 100 and less than 100, no, 100 and 125, That's in the inelastic portion of the demand curve. So you don't actually have to answer this to work this all out to answer this question. You can just look here and pick the inelastic number, the one that's less than 1. But we'll be good students and we'll actually do the math. So the formula you want is right over here. So the change in output with respect to a change in price, Q2, quantity at the second price minus quantity at the first price, divided by Q2 plus Q1 divided by 2. That's the midpoint part. P2 minus P1 divided by the midpoint between those 2 points. That's 42 minus 48. I read that off the graph down here. Divided by 50, that's 42 plus 48 divided by 2. And that actually can't be right, can it? 50, 90. No, that's not right. This should be 45. So call that 45 instead of 50. And then this one, P2 minus P1, that's 100 minus 125. The midpoint is P2 plus P1 divided by 2. That's 100 plus 125, 225 divided by 2. Okay, that really is 112.5. Let's do that math. You come up with this answer, 0.6. That's inelastic. That means that people are not particularly sensitive to a change in price. They won't change the amount they purchase by very much. So that's inelastic. That means that they won't change how much they purchase. So a $25 per bike decrease will actually lead to a decrease in total revenue per day. So a decrease in price is going to lead to a decrease in total revenue. And that happens because people weren't very sensitive. So we put those bikes on sale, but it didn't cause very many people to come in and buy more bikes. So you actually lose revenue overall if you decrease the price. On the other hand, if you increase the price, you earn money because, again, you increase price quite a bit. Nobody cares. They keep buying the bikes anyway. So total revenue goes up. So think about that for a while and maybe do the math on a couple more of these. If you have any questions on the first problem, give me a call. Thanks. Bye-bye.